All right, so we're keeping with our theme here, and we're still working with circles. Today we're going to work with section 10-4, which is all about inscribed angles. So we're going to draw a lot of pictures today of circles with angles inside them. And we're going to start out with something to remember. So remember, if you see a picture like this, where we have A, C, B, and we know that this is x degrees. So remember, the central angle, right? We've learned about central angles. Remember that the measure of arc AB is equal to the measure of angle ACB. Right? That's something that we already know. So now we're going to do an inscribed angle. So this is not an inscribed angle. This is a central angle. An inscribed angle looks different. So we have a circle, and an inscribed angle is going to go all the way to the other side. So hopefully we see the difference between the central angle, which starts at the center, and the inscribed angle, which has its points all on the edge of the circle. So we'll say this will be angle ACB. Okay, and the way we talk about it is that angle ACB is an inscribed angle. And arc AB is an intercepted, so that's a new word, arc. So we have an inscribed angle and an intercepted arc. The intercepted arc just means that it's the arc that's kind of inside the mouth of the angle, or the opening of the angle. So that's the intercepted arc. So when you read something about an inscribed angle and an intercepted arc, it's nothing super fascinating. It's just what the words mean. Now, the most important thing to remember about this picture, or an inscribed angle, is that the measure of angle ACB is equal to 1/2 the measure of arc AB. So if you think about that in the opposite direction, the measure of arc AB is equal to 2 of the measure of angle ACB. Okay, so we're going to look back up at our central angle picture. Remember, with our central angle, so our angle's in the center, the arc right here and the angle have the same measurement. If our angle's all the way across to the other side of the circle, then our arc and our angle have a relationship, but they're not the same. So the arc is double of whatever the angle is. So if this is 20, the arc is 40. If this is 50, the arc is 100. If the arc is 60, the angle's 30. Not real complicated, just something you got to be able to recognize. So we're going to do a quick example. So let's say we have x, y, and it says this is 30 degrees. And we want to know what's the measure of arc xy. Well, we know that the arc out here, xy, is 2 times the angle. So it's 2 times 30, so 60 degrees. So nothing exciting about it, very simple. All right, we're going to write down another rule about inscribed angles. This one says if two inscribed angles, and it'll make so much sense when we draw the picture. If two inscribed angles intercept the same arc, or congruent arcs, then the angles are congruent. So here we have our circle, and we're going to put an angle inside it. So we're going to have that angle there. That's going to be angle ACB. So ACB. Well, you know that there's this arc here, right? This arc from A to B. So that's arc AB. Well, if we throw in another angle that goes from A to over here back to B, the idea here is that angle ACB is equal to, sorry, congruent to angle ADB. Hopefully that makes sense to you, because the measure of angle ACB equals 2 times the measure of arc AB, and the measure of angle ADB equals 2 times the measure of arc AB. And so if you remember, by our substitution property, don't worry, we're not going to do any proofs. Don't start freaking out. No proofs, just by our substitution property, the measure of angle ACB is equal to the measure of angle ADB, and that means that the two angles are congruent. So that's how this works. If you see two angles that hit the same arc, then the two angles are congruent. Not too bad. One more rule, and then an example. Actually, just two more rules. An inscribed angle of a triangle intersects a diameter or semicircle, or if it intersects a diameter, that's kind of the same thing as a semicircle. If and only if the angle is a right angle. And again, these all make so much more sense when you see the picture. So we have a circle, we have a diameter, and what we're saying is that if an inscribed angle intersects a diameter, then that angle must be a right angle. And it should make sense to you, because if we intersect here and here on the diameter, so say this is point C, center of our circle, and this is A, B, D. So if AD is a diameter and our angle intersects that diameter, that means that this arc right here is 180 degrees, right? Because it's half of the circle. Well, that means this intercept, or this inscribed angle, has to be half, right? And 180 divided by 2 is 90 degrees. Okay, so when you see a picture like this with a right angle that hits a circle like that, it may not tell you that it's going to be true that AD is a diameter and angle B is a right angle. Okay, so when you may not see the right angle, you may just know that's a diameter. Or you may not know it's a diameter, but you may see the right angle. And both of those tell you that AD is a diameter and angle B is a right angle. All right, last rule. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So circle, quadrilateral, inscribed. So we'll call it quadrilateral A, B, C, D, like that. So if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So that means that the measure of angle A plus the measure of angle C equals 180. And the measure of angle B plus the measure of angle D also equals 180. Okay, that should all make sense because the measure of angle A plus the measure of angle C equals 1/2 of arc BD, right? So measure of angle A goes to arc BD right here, right? That's the measure of angle A. Plus measure of angle C is 1/2 of arc DB. So the measure of angle C right here is from here to here, right? Well, what does all that add up to? That adds up to 360 degrees, right? And so that equals 1/2 of BD plus DB. So we add the two arcs together. So that's 1/2 of the 360 degrees that the two arcs add up to, which equals 180 degrees. Okay, so all of this is not super important that you remember. This is the important part, that you can remember that this angle and this angle add up to 180 degrees, and this angle and this angle add up to 180 degrees. But if you're interested, that's how you prove it.